Hello, differential equation students. We are going to solve this differential equation using Laplace transforms. I've put over some important information from Wednesday's class. We've got this equation for the Laplace transform of an exponential, and from Friday's class, this formula for the Laplace transform of the derivative. All right, when you want to solve something like this, the first thing you're going to do is you're going to take the Laplace transform of the equation. So what we're going to do is L the equation. So that means on the left-hand side, we have the Laplace transform of the derivative, and on the right-hand side, the Laplace transform of negative 2y. What can we do with this? Well, notice that I've got the Laplace of the derivative, and there's the formula right there. How does this work? My left-hand side turns into s times the Laplace transform of y minus my function at 0. Hey, I actually have a formula here for my function at 0. It's 8, so I've got minus 8. On the right-hand side, because L is a linear operator, I can take out the negative 2. So I've applied the Laplace transform to the equation and gotten this. Next thing you're going to do, solve for the Laplace transform of y. So you note that that shows up on both sides of the equation. So actually, if I rewrite this, I'm going to get s times the Laplace transform of y plus 2 times the Laplace transform of y equals 8. Or, solving for the Laplace transform of y equals 8 over s plus 2. I'm going to write that as 8 times 1 over s plus 2 to kind of indicate the fact that we've got a constant times this expression. The last thing we need to do is to go back to y. So we sometimes talk about this as the inverse Laplace transform. What's happening here is that we're saying, all right, I have this form. How does that match up with what I know for Laplace transforms? And I can see, all right, my y is going to have an 8 in front of this. You can see right here that this form is what I would get if a equals negative 2. If a equals negative 2, then what I have is e to the negative 2t. That's the solution to my differential equation. So keep in mind these 3 steps. Laplace transform the equation, solve for the Laplace transform of y, do the inverse Laplace transform. Now, of course, you can solve this by separation of variables, or you might even be able to see the solution. This method that we're using is what we're going to be using all the time in Laplace transforms, and it will be useful for harder and harder differential equations. All right, I hope this made sense. If not, please ask me during class, and I'd be happy to explain any portion of this.